Hi everybody. The purpose of this video is to go over the second part of section 2.5, specifically the applications that you'll have to do in homework B. And this is what I have set up for you. Notice that on the left hand side of the screen I actually have the homework problems, and there happen to be 6. They'll be the you will have the identical problems. It's just that the numbers may be different. I have over here OneNote, which I'll be using as my scratch pad or scratch paper, and on occasion I will need to use my TI-84 calculator, and my computer emulation of it is right here. So let's go ahead and get started. Okay, question 1. We have to find the value of an investment of $15,000 for 14 years at an annual interest rate of 3.85% compounded continuously. So for this particular problem, we are dealing with what we call a continuous compound interest problem. And the formula for that is going to be A is equal to P times e to the RT, where A is the future value. Let me do this a little differently. The present value is P. The interest rate, or R, I guess I'm going to do it this way, is the interest rate as a decimal, and then T is time in years. Okay, so A is actually what we are looking for. P, which is the present value, is the amount that you invested. So in this case, P is $15,000. R is your interest rate in decimal, but you have it as a percentage. So R is going to be 3.85, but that's a percentage. To turn it into a decimal, you need to divide that by 100. And if you do, you're going to get 0.0385. And just to be sure about that, here's my, oh, no, not yet. There it is. Here's my calculator. We have 3.85% divided by 100. And look what I get. I get 0.0385, which is exactly what I have down here. Okay? And then T is 14 years. So we have P, we have R, and we have T. So we have everything that we need to figure out this equation. Okay, so let's go ahead and do that. Let's go ahead and do the substitutions. We are going to have that A. A is what we're trying to find out, and that's how much we're going to have at 14 years. That's going to be equal to 15,000 E raised to the R, which will be 0.0385 times T, which is 14. And you might be asking, well, what in the world is E? Well, E, whoops, I wanted to change pens there. E here is Euler's number. In other words, 2.718 ... But this is the calculation that we want to do in the calculator. And of course, the other question is, well, how do you put this in the calculator with this E here? Well, that's what I'm going to show you. So here's my calculator, and this is how you would do it. We will type in 15,000 times, and then over here, you see where we have the ln key and the e to the x? That is what we're going to use to do the rest of that is what we're going to use to do this part of the calculation. So I'm going to come over here and do second ln, which gives me the e on my little exponent there. And up there, I'm going to type in 0.0385 times 14. Once I have all that in there, all I need to do is to hit enter, and that right there is my answer. Writing that down, I have $25,714.37.57. Now, chances are we want to express this to the nearest cent, which is basically to the hundredths place. Okay. Well, notice here I have a 5, and so we have a 5 or higher. We want to round up, so this will be $25,714.38, and that is what we want to put in here. 25714.38. And there you go. So that's how we do problem 1. Let's take a look at problem 2. Suppose that $4,000 is invested at a 3.6% annual interest rate, which is compounded monthly. How much money will we have in 6 months? How much will we have in 7 years? Now, this is what we call the compound interest formula. And the formula for that is as follows. A is equal to P times 1 plus R divided by M raised to the MT power. Well, what the heck is all this stuff? Well, if we are compounding, well, right now, A is the future value, how much we're going to get back. P is how much we're investing, so that's the present value. In this case, it will be $4,000. R is the interest rate as a decimal. M is the compounding frequency. And T is the time in years. Now, so once again, the future value is the thing that we're trying to find. The present value is $4,000. The interest rate is, as a decimal, is going to be 3.6% divided by 100, which will give you 0.036. Your compounding frequency, since we're compounding monthly and there are 12 months in the year, is going to be equal to 12. Okay, so if they tell you, if they give you a compounded thing like compounded monthly, daily, just think, or weekly, just think about how many days there are in a year, or weeks there are in a year, or months there are in a year, and you'll be able to figure that out just fine. T, of course, is, in this case, 6 months, but we can't do months, we have to do years, and 6 months is 1/2 of a year, so that's going to be 0.5 years. Okay, so then our equation is going to be that A is equal to 4,000 times 1 plus 0.036 divided by 12. Okay, all that raised to the 12 times 0.5 power. And the big question here is, how do you put all this stuff in a calculator? Well, let me show you how to do that. Here's our calculator. All right, now, there's a couple of ways to do this. One way is just pretty much writing out the entire equation. Let's go ahead and do that. 4,000 parenthesis 1 plus 0.036 divided by 12, close the parenthesis. Now this is our power symbol. If we click this, we will get our exponent. And then we can put in 12 times 0.5 and hit enter. And we get an answer of $4,072 and basically 54 cents when you round. Now, another way to do this, if you may be more comfortable with this, is to do what's inside of the parenthesis. That would be 1 plus 0.036 divided by 12. Okay, so we have all that. We can raise that. We can raise this quantity to that particular power because we want to do. That's the next order in the order of operations. So we can raise, and all we need to do here is just hit power, and it'll take the answer, previous answer, and give you an exponent. And here we can do 12 times 0.5. Okay, and then it's our answer there. And then all we have to do now is multiply that by 4,000. And as you can see, we have the exact same answer. So it really doesn't matter how you do it, it's what you are most comfortable with. So what do we have? We have that A is equal to $4,072 or $0.542. And since that's less than 5, this will round to $4,072.54. So that will be 4072.54. And I did not screw that up. Okay, now the only thing that's changed here is T. Everything else is the same. The only thing that's different here is that instead of T being 6 months, T is now 7 years. So instead of having 12 times 0.5, we are going to have 12 times 7. So what is that going to look like? Well, in this particular case, we will have A. Everything will be the same, except the time is different. So instead of 0.5, we'll have 7. And we will have that A is equal to 4,000 times 1 plus 0.036 divided by 12 raised to the 12 times 7 power. And the question is, how can you do that in your calculator? Well, actually, since your calculator actually has a history and remembers what you've done before, what you can do, particularly if you did it like this before, is you can go up and highlight that equation or that calculation. Not that, but this one, and hit enter. Okay? Now what you can do is we can change the 0.5 to 7. And the way you can do that is with these cursors. Just back it up to the point, hit delete again. So the 0.5 is gone. Add the 7, hit enter. And that's what your answer is. Now you can do it the way that I did it before, which is 1 plus 0.036 divided by 12. You can just go up there and highlight that. Hit enter. There you go. Okay, and then you can, well, at this particular point, you can do you can then do the exponent, which will be hitting caret 12 times 7. Okay, and then once we have that, we just multiply that by 4,000 times 4,000 for 1, 2, 3. You could use the history or just do it here. And look, you get the exact same thing. So what we got was that A is equal to $55,144.443, and that will round to $5,144.44. There you go. Okay, question 3. Question 3, once again, is a finance problem. We're kind of getting you prepped up for, we're trying to get you prepped for chapter 3. A person wishes to have $16,900 cash for a new car 4 years from now. How much should he be placed into the account if the account pays 6.7% annual interest compounded weekly? Okay, so notice here that we have $16,900 of cash, which he wants in 4 years. So in the future, he wants $16,900. And the question is, how much should he put in at the present so that 4 years in the future, he has this? This is the future value. We need to figure out what the present value is. Okay, so let's go ahead and do that. Also notice that we have a 6.7 interest rate, and we're compounding weekly. So we're using the exact same formula we used before. That is A is equal to P times 1 plus R over M raised to the MT power. This is future value, present value, interest rate as a decimal, the compounding frequency, and then the time in years. Now notice that since we are compounding weekly, and there are 52 weeks in a year, M is equal to 52. Remember, the 16,900, that is our future value. That is A. P is the present value. That's what we want to figure out. How much do you need to put in now to get $16,900 later? R is our interest rate as a decimal. That is going to be 6.7% divided by 100. Yes, that's supposed to be a percent sign. And that will give you 0.067 as a decimal. Okay? And then T is 4 years. So T is equal to 4. Okay, putting all the numbers in, we have that 16,900 is equal to P times 1 plus 0.067 divided by 52 raised to the 52 times 4 power. Okay, so remember, we're trying to find P, and so it might be best that we isolate this. And one thing that you could do is you could compute all this, get a number, and then divide it out by that number. And that typically is a good way to do it. The only danger is that if you round off too early, you might lose some information. The way I'm going to try to do this is in its current form, and I'm just going to divide both sides by this entire quantity. Okay, so I'm going to divide over here by 1 plus 0.067 divided by 52 raised to the 52 times 4 power. And over here, I'm going to do the exact same thing. 1 plus 0.067 divided by 52. All that raised to the 52 times 4 power. What happens? Well, this right here, this is equal to 1. This cancels. All we have over there is P. Kind of flipping it around. Then over here, I have 16,900. Supposed to be a 6, sorry about that, divided by 1 plus 0.067 divided by 52 raised to the 52 times 4 power. Okay, and so we need to knock, and let me make sure you guys understand that that is below the fraction. So that right there is our fraction. And the big question is how the heck do you do this in the calculator? Well, here's how I'm going to do it. You could do it in one step. I think in this particular case, it might be easier to do it in another step. First thing you want to do is compute the value of the denominator. And the way you can do that is just simply, well, not simply 1, no, my mistake, let's back up, parenthesis 1 plus 0.067 divided by 52, close the parenthesis, power, exponent, and then 52 times 4. Well, that's 52.4. We don't want that. But notice how I can correct that mistake. I can just basically move on over it. I can hit times instead, and then I'm perfectly fine. But notice here, this looks exactly like the denominator. So when I hit enter, that is my value for the denominator. So now all I need to do is divide 16,900 by that quantity. And that's what I'm going to do. 16,900 divided by, now I'm going to highlight this number. You could highlight that if you wanted to. They're both the one and the same thing. Divided by that, hit enter, it brings it down, hit enter again. That is my answer. So what do I have for an answer? I have $12,929.171. Okay, and if I look at this, I realize I do not need to round up, so I will have $12,929.17. That's how much I need to invest now to get $16,900 in the future. Oh, and also, we are rounding to the nearest dollar. So if you are going to round to the nearest dollar, and I have a 1 here, we can just keep that at $12,929. 12,929, and that is correct. Okay, question 4. A couple just had a baby. And the question here is, how much should they invest now at 5.5% compounded daily in order to have $35,000 for the child's education 18 years from now? So they're planning for college, something I highly recommend when you guys have children, if not sooner. Okay, so once again, we have 5.5% interest, and it's being compounded daily. So this is a compound interest problem. So we have A, our future value is equal to P times 1 plus R divided by M raised to the MT power. Once again, this is how much we want to have in 18 years, $35,000, which might pay for a year of college. So $35,000 is what we want to have in the future. That is our future value. A is equal to $35,000. R is our interest rate as a decimal. That's going to be 5.5% divided by 100, which will be equal to 0.055. M is our compounding frequency. Since we are compounding daily, and there are 365 days in a year, or at least they're telling us that that we can assume that, we can say that M is equal to 365. And of course, T is equal to 18 years. So this is just like the previous problem, except we have a different value for M. So writing this out, we have that $35,000, that is A, is equal to P, that's what we want to figure out now, times 1 plus 0.055 divided by 365 raised to the 365 times 18 power. Like before, I'm going to divide both sides by this quantity. So 1 plus 0.055 divided by 365 all over this monstrous 365 times 18. And we're going to do the exact same thing on the other side. 1 plus 0.055 divided by 365 raised to the 365 times 18. Yeah, I'm running out of space. Of course, these will cancel. What I will have over here is P. That will be equal to 35,000 divided by 1 plus 0.055 divided by 365 raised to the 365 times 18. Okay, and that's what we want to put on our calculator, and we're going to do it the exact same way we did it before. Essentially, we're going to do the denominator first, and that is going to be parenthesis 1 plus 0.055 divided by 365, close the parenthesis, power 365 times 18. 15. Okay, hit enter. That is our denominator. Okay, so now what I want to do to figure out my present value, I want to divide 35,000 by this quantity right here. That'll be 35,000 divided by, you don't need to write this in, just go up there and highlight it, enter, enter. That should be your answer. Now they want this to the nearest dollar. Okay, we can do that. I should have checked that before I did the last problem. So we will have that P is equal to 13,000 $6.15. Okay, so basically here we have a 1. That's less than 5. You do not need to round up. This would be equal to $13,007. No, $6. Sorry. Actually, you should put in 7 because if you don't, you're going to be a little less. But I don't think that they're trying to be all that particular about that. So if they're not, then I'm not. Okay, so let's put this back into, let's put that entry into MML and see what happens. 13,006. 6. There you go. That's how that one is done. Okay, we only have 2 more left. Okay, now this one is what we call a exponential regression problem. So this is what we have. We have the table shows the number of internet users worldwide since 1994. Let X represent the number of years since 1994 and find an exponential regression model, y equals a b to the x for this data set. Okay, so what the heck do they mean? Well, the first thing is that they want X to be equal to the number of years after 1994. That is years minus 1994. So the years so let me make a little table here. Here is the years. This is X, and then over here we're going to have X, which of course is going to be years minus 1994. Okay, so if the year is 1994, X is 0. If it is 1997, 1997 to minus 1994, that's going to be 3. 2000, 6. 2003, 9. 2006, 12. Notice how we're incrementing by 3 all the time. 2009, 15, 2012, 2012. That should be 18. All right. And then Y is going to be users. Users, that is Y. So here we would have 2.3, 17.7, 70.3, 158.7, 393.4, 586.4, 949.8. So this right here is the data that we actually want to put into our calculator to do a linear regression or to do an exponential regression. So how do we do that? Well, first we need our calculator. Here it is. To do this, we need to go into stat. Okay, so we want to click stat, and the first thing we need to do is put in our data. So we want to edit. And here we are already at edit, hit enter. Now, if you have stuff in here, you need to get rid of it. So we can do to get rid of stuff in L2, you can go up, highlight L2, hit clear, hit enter. It's gone. Go over to L1, do the exact same thing. I forgot to hit clear. There we go. Okay, once you've done that, we can put in our data. Now notice the first column is going to be basically 0 through 18 in increments of 3. So we're going to have 0, 3, 6, 9, 12, enter, 15, enter, 18. enter. I forgot about that little detail about hitting enter. And then this column is going to be these numbers right here. And really, remember, these numbers is nothing more than just a duplication of these particular numbers right here. So we're going to have 2.3, enter, 17.7, enter, 70.3, enter, 158.7, enter, 393.4, enter, 586.4, enter, 949.8, enter. Okay, so let's just make sure they're right. 949.8, 586.4, 393.4, 158.7, 70.3, 17.7, 2.3, 0, 3, 6, 9, 12, 15, 18. Okay, so that looks right. Okay, now that we've all done all this, we're going to go hit Stat again. Now we're going to go to Calc. Now remember, we are trying to do an exponential regression. And there is something that says that in here somewhere. It's just not there. It is right there. EXP-REG, that stands for exponential regression. So once we highlight that, we just hit enter. Okay? Now our X values are in L1, our Y values are in L2. That's what we want. So we can come down here and we can hit calculate. All right? And then these are our numbers. 5.66214846 for A, that's what's going to go here. And then 1.37570 and so forth for B, that's what's going to go here. But before we do that, let's just go ahead and write them down. Because remember, we want these to 4 decimal places. So let's come over here. Let's type in A. A is equal to 5.66214. This is the 5th decimal place. It's less than 5. So this will round to 5.6621. B is going to be equal to 1.37570. Well, that's 0, so there's no rounding here either. 1.3757. Okay, let's see if this is correct. .6621, and then here we have 1.3757. Check our answer, and there we go. Now the next part is we want to use this model, this equation right here, to estimate the number of users in the year 2030. Now remember, so to do this, all we need to do is to figure out what X is. Well, remember, the year that we're looking at is 2030. And therefore, X is going to be 2030 minus 1994. 2030 minus 1994 is equal to 36. So X is equal to 36. And once we have that, we are pretty much off to the races. We have this number, we have that number, we know that X is equal to 36. So Y is going to be equal to 5.6621 times the quantity 1.3757 raised to the 36th power. How do we do that in your calculator? Just like, well, once we get the calculator up, I'll show you. Just like this. Just type in 5.6621 times 1.3757, exponent 36. That should be your answer. However, they want this to the nearest million. And what do we have? We have 549, 328. It's not over far enough. 0.4 315. Now notice here, that's less than 5. So this is going to round to, well, over here, 549, 328, which is what our answer should be. 549, 328. And there you go. That is your answer. Okay, moving on to our last problem. Okay, this particular problem is not nearly as difficult as it appears. So let's go ahead and read this. Suppose that the population in some state in 2010 was P equals to 31 million, and its annual percentage rate of continuous growth is R is equal to 0.01%. And the first part is write the formula f of x is equal to P times e to the Rx, where R is in decimal notation that models the population in millions X years after 2010. So, the formula is of the form f of x is equal to P times e to the Rx. And they tell you that P, at least in the year 2010, is equal to 31 million. So now we have that f of x is equal to 31 e to the Rx. So all we need to do is figure out what R is. So we get R from capital R. R over here is 1.01%. Little r is basically in decimal notation, it's capital R in decimal notation, so it's going to be 1.01% divided by 100, which will be 0.0101. So that's R. And that tells us that f of x, just putting in 0.0101 here, is going to be equal to 31 e to the 0.0101 times x. Okay, and all we need to do is put that in here. So go ahead and click on this, and we can type in 31. Now for the e, you can use the e down here, or you can just type in e. And then for the exponent, you can use this little button right here, and then we will just type in 0.0101x. And there you go. And then the very last thing you need to do is estimate the population in 2012. Well, you're basically going to use this formula. You just need to figure out what x is. In this particular case, x is going to be equal to 2022, the year of interest, minus 2010. 2010, which will be equal to 12. So x is equal to 12. So f of 12 is going to be equal to 31 times e to the 0.0101 times 12. And we just need to knock that out in our calculator. So here is our calculator. It's going to be 31 times, and now remember, since we're doing, we're using Euler's number here, that's this value right here, and we can get that by doing second natural log, which is good because it's the e to the x, and then we just type in the product of the exponent right up in here. 0.0101 times 12. And that's what we get. Now notice that they want us to round to a whole number. And what we get here is 34.9. And since that's greater than 5, this will round to 35. Okay. And that is how you do your application problems. If you have any questions, please feel free to contact me. I'll be happy to work with you on these. And this is Bob Boyle, signing off.